Hey, welcome back to Physics 263 Astronomy. This is section 12, where we're going to be talking about our own galaxy, that's the Milky Way, but also understanding that there are other galaxies, about 2 trillion of them, and we're also going to start discussing our own neighborhood before moving into real extragalactic astronomy in sections 13 and 14. As always, you'll find all the details in the lecture notes, and in this playlist, I'll try to highlight the most important contents. In section 12, we're really doing an introduction to galaxies. We're going to start with our own Milky Way and how we determine our position within the galaxy. We're going to be looking at different stellar populations that exist in different components of the galaxy, and also the different components of the galaxy, including the bulge, the disk, and the halo. We'll see how galaxies and star clusters end up being different, and that the key difference is actually something we were unaware of until the 60s and 70s, which we now call dark matter. And finally, we're going to be looking at how Hubble came up with the classification scheme, and also how we live in a local group, and essentially how galaxies group together, something that we will then discuss even further in sections 13 and 14. As soon as humankind realized that we weren't in the center of the solar system, the next big question is, were we in the center of our galaxy? Back then, we thought our galaxy was much smaller. We can only see essentially the solar neighborhoods, but we still thought that that was pretty big. Trying to address that question, this guy over here, Herschel, tried to determine our position within the galaxy. And essentially, what he did, because people started being able to measure parallaxes, they could determine the distances to nearby stars, he would actually map from our position, essentially outwards, to see how many stars there were in each direction. The conclusion was that essentially we seemed to be in the center of the galaxy. We could see stars essentially at all directions, and it seemed to be like they would stop at some distance. But the important question to address is this really the case? A significant challenge in determining our position within the galaxy is that this is pretty much the same as trying to determine your position in traffic if you're under really intense fog. Essentially, if you do that, you can't really see much further away, and therefore you will actually see the same amount at all directions. It doesn't mean you're in the center of the universe. Now, the reason for this fog in the galaxy is dust, and also the fact that stars become dimmer the further they are. Remember the 1/d² law? But just like for fog, typically the column density, or the amount of fog you're looking through, is much higher on this direction than, for example, if you're actually trying to look up. Specifically in our galaxy, these lights exist. There's quite a few of them, and they're called globular clusters. Now, a way that we were able to determine our position within the galaxy was to look out of the fog and actually try to measure the orbits and distribution of these lights that are outside the fog or the disk. And that allowed us to really understand what was the galactic center and our position within it. In reality, this is what we were able to figure out. This is the sun and the Earth. The center of the Milky Way is definitely not at the sun's position, it's here. And the way that we were able to determine the center was essentially by looking at the orbits of globular clusters and seeing that even though they have kind of random orbits in different directions, they all orbit the center of gravity, which is the center of the galaxy.